What's up, fam? It's your boy Osiris back at it again with another video. Today I'm going to be doing a little bit of computer programming. I'm working on a little data science project. Basically, I'm building a lyrics analysis bot. I want to run some stats, some natural language processing algorithms, and some stats on music lyrics, so that musicians and rappers and songwriters, whatever, have this tool that they can use on Twitter for free to analyze their music and gain a better understanding of what they're doing with their art. So basically the idea is that I want to take song lyrics from let's say like a genius.com link, and then run it through this, run some calculations, make some charts and graphs and shit, and then send that to them so that they can use it in their work. Okay. Now, I actually already made this whole video before. I made it yesterday with a face cam, but long story short, I had some tech problems, and it didn't work out, so I had to remake the video. That's why I already have the code file written, but I didn't do very much. I just did the pre-processing steps. Hold on. Sorry, there's a plane going by. I live near the Cincinnati airport, so it's a little annoying. So I'm going to talk a little bit about some of the pre-processing steps that I got done yesterday. So when we have these lyrics, we want to pull in the text, and we actually want to run some processing algorithms on that first. So for example, we want to remove stop words. So what does that mean? Well, a stop word is like the, or and, or in. These are words that don't really affect the meaning of a song. So whenever we're doing analysis on the lyrics, we want to, we want to get rid of things that don't affect the context or the meaning. By the way, I am analyzing actual real music with this algorithm, so keep in mind, there's probably going to be a lot of offensive language on the screen. Yeah. So anyways, removing stop words is one of the first things you want to do. So in order to do that, what we do is we use an import function. I'm using Python 3, by the way. I'm running this on Ubuntu 1904. That's my OS. So what you do is you import the stop words from NLT to k.corpus, and then you basically just pull out the set of English stop words and define that in your script. So later on in the script, where is it? Oh my god, I'm lost. I have like 12 lines of code and I'm freaking lost. Okay, so right here, this is what we do basically after we take the lyrics. We will tokenize, which means that we take the lyrics and we actually split up each individual word so that we can analyze each word individually. And so this variable here, word tokens, these are all of the individual words in the song. And I'll show you an example up here. This is Gucci Gang by Lil Pump. So for example, the word scream. The word scream is in the song, so that's one of the word tokens. That's one of the pieces in that variable. Okay, so we look through each of the word tokens, and then we say if it's not a stop word, then we're gonna move on. We're gonna move forward with that word. Okay, so we take that word. Where is it? Right here. This W variable. That's the word. Okay, so that's like the word scream. Okay, we convert it to lowercase. I'll explain why in a second. And then we stem it, and then we add it into the stem sentence. Okay, now this variable name is actually not very helpful because it's not a sentence. It's actually a collection of words. So the term sentence wouldn't properly describe that variable. Anyways, so this is how we get rid of those words like a and the and stuff like that. Now we want to convert to lowercase because there may be different instances of the same word in the song, where like one of them is lowercase or one of them is uppercase, and we don't want to consider those separately. Like it's the same word, it means the same thing, so we don't want to, we don't want like 8 different versions of the word scream, like one that's lowercase, one that's uppercase, one that maybe they just So anyways, I'm not going to go too much into all these different things. I just want to give you a quick run through. One of the things we do is we do part of speech tagging, aka pause tagging. Okay, so this is important because, you know, in the song you may have two different variations of the same word, like fish, to cast a reel. This is a verb, okay? But we also have the word fish, which is a water animal. That's a noun, right? So you can fish, like as an action, or you can have a fish, which is an object, right? And in the context of the song, when we are running analysis on this, we need to be able to differentiate between both of those different variations of the same word. So that's why we use this pause tagger, because that's going to give us more context. So, for example, I don't know, let me see a good word here. Okay, so, you know, like, basically, like, if you look here, I guess this is a bad example, but if you look at the word bitch, that's a noun, right? And if you look here, here's a good example, okay? So this is the word love, but it's classified as a noun, not as a verb. So in this specific example, the algorithm has identified that this use of the word love is not being used as a verb, like I love you. It's being used as a noun, like I have a lot of love for this song or whatever. So we need this information so that we can better understand what they're actually saying. Another thing we do is we stem words, which means we take all the different variations of a word and we convert it to the same base, the same stem. So if you have the word master, mastery, or masterful, those are all really the same word. They all kind of have the same meaning. They're slightly different, right? But they're all kind of the same thing, so we don't want to have, like, again, like I said, sorry, you don't want to have like 8 different variations of the same word, right? Because then that's just adding in a lot of noise to the analysis. Okay, so this up here, this is actually the list of stems. So, and there's actually an error on here I'll talk about in a second. But, okay, so let me find a good example here to kind of explain how this works. Well, actually, no, I mean, I guess this right here, this is a fine example. So, in our set, if we have these 3 different words in the song, we're not going to see all those 3 different words here in this list, because these are just the stems. We're just going to see the one, okay? And down here, if you see this 92, what I've done is I've calculated the number of stems, which means the number of unique words in the song. So that's not the number of total words, that's the number of unique words, okay? Now, there is a glitch here, actually. The algorithm was not able to properly stem the word fuck, because I guess maybe it's not configured to process cuss words or something like that, although there's a couple here that look like they were properly processed. So I don't know why the algorithm messed that up, but basically these 2 words should just be fuck. Like this it's the same stem, you know what I mean? So there's a little bit of a glitch there, and that's one thing that you have to keep in mind when you're doing data analysis, is that there will be errors and there will be noise in the data. So this stuff is not 100% accurate. It doesn't work perfectly all the time. But let's go in and start writing some more code. Let's start running some stats here. Okay, so first of all, I'm gonna take this out. I don't really want to see you know, the parts of speech every time. So let's see what we got here. I don't know why this thing is so long. Okay. Okay, so we've got the unique words, we got the stems, and we've got the stem count. So let's start making a little bit of output here, a little bit of, you know, a little bit of a GUI, if you will. No, let's call it this. Okay. I don't even know how to use the print function because I'm not used to working in Python 3. So let's see here. Okay. So we're going to create a new variable called stem count. So this is going to be like our first official statistic coded into the bot. And if you see, I actually just calculated it on the fly, but we're just going to put that there. So now I have the same effect. So now I have the same effect, but it's I'm basically just refactoring the code, if you know what I mean. And I really do need to refactor this code because I kind of just threw it together real quick. Thanks, Sublime Text. See you later. All right. So now we have this thing right here. So we're starting to get a little bit of a percentage of the text is unique. Another way to say it is that, if you have a song with a lot of repetition, a lot of the same, like they repeat the chorus over and over and over again, it's kind of like they're not really like adding in any new words, they're just repeating the same words. So you would say it's not a very lexically diverse text. So let's try to calculate that statistic as well and see what happens. Okay, so it's lexical diversity on the text. So let's go ahead and set up the print statement. Oh shit. Autocomplete, I hate you. Okay. Okay, so we're gonna actually calculate this stat. We're just gonna call it lexical div, because lexical diversity is the name of the function, so I have to use a different variable name. Where is it? Okay, I guess it's word tokens. I don't even know what this function takes as input, honestly. So this is like a little bit of experimentation right now, if you know what I mean. Okay, now I do need the autocomplete. Oh, come on. Okay, of course, now that I need it, it's not even working. So let's go with this. So let's see if we can print this out. Let's hope that it just works right off the bat. If it doesn't, I'm gonna have to go back in and like look at what this function takes as arguments or something. Okay, so there we go. It actually worked. Hold on. Airplane. Someone just got back from vacation. Okay. Oh, you know what? I want to show you a cool thing here. So we want to actually round this off. So I think there's a round function in Python. Let's see if that works. I don't even know for sure if that actually works or not. Okay, yeah, so that didn't work. So let's see if this works. Okay, perfect. So what we did there is I used the round function in Python. It takes two arguments here. This is the first one. This is the lexical diversity that we just calculated before, but it strung out like 8 different, it went out to like 8 different digits. I don't need that much information. Like, in fact, really, I only need like maybe like 3. Because right now we're just taking a look at this stuff. We're not really like doing anything yet. Okay, so right now I'm starting to build these statistics. You see this? Oh, and by the way, keep in mind that this is a percentage. So it says 0.3. That means 30%, right? You understand that, right? Now, what some people will do is they'll actually multiply it out by 100, so that it actually is a percentage, right? So it's like 30%. But I don't like that. I'm a mathematician, and the way we do things is, typically in math we like to see percentages like this. I mean, I don't know about you guys, but that's just me. That's just my personal preference. And that's the way I typically see it when I was using MATLAB. Anyways, so you know what? I'm actually just gonna go ahead and get rid of this. So now we're only producing statistics. Okay, so you see now every time we run the script, we're just getting stats. So we're not seeing all these words and crap. We don't want to see all that right now. That's more of like a debugging kind of situation, you know what I mean? Like how I said that it didn't properly stem these 2 words, right? So what I would do, if I were debugging, like if there was an error with that, is I would go back in and I would uncomment this line so that I can take a look at the unique words and say, oh, that's the error right there. It's because that, right? So from now on, we're just going to be using that as a debugging tool. All right. Okay, so now we got a couple stats going. Let's see what else we can do. We can do a word count. This one's going to be a little tricky because we do a lot of pre-processing on this data, so I'm not sure exactly where we should put the word count. Like, we could do it on the word tokens, but that's before the stop words. Actually, yeah, that would be proper because, so let me show you something with the pre-process function. What I'm doing here is I'm stripping the text, which means I'm removing all the white space. Like if there's just a bunch of spaces at the end of the text, I want to get rid of that. That's not part of this. Okay, and then I have the char strip, which just does a regex to get rid of all the symbols like question marks and apostrophes and all that shit that doesn't have anything to do with like the content of the text. That doesn't mean anything. So we're just taking that out right off the bat. So that's what the pre-processing is doing. So I guess after this point would be the proper time to do the word count. So what we're actually going to do is we're just going to use the length of the word tokens variable because, like I I said, this variable here represents all of the different words in the song. So let's add that one in there as well. Okay, so this should give us the total word count of the song, and we'll actually do another word count in a second to show you something different. Okay, so in this song there's 428 words, and then we want to look at the unique words. Wait. Hold on a second. Okay, you know what? Actually, let's make another variable. This one's going to be a little weird. We're going to call this significant words. So remember when I was saying that I didn't know where to put the word count? It's because we're doing different steps of processing. So after I take out the stop words, or well, no, hold on a second. It's the stems. But it wouldn't be unique. No, yeah, okay, yeah, we will do that then. We will do that then. So that is the stem count. So we will actually just refer to this. We're going to put this down here. Okay, we're going to refer to this as the unique word count. Now, that term is actually not necessarily a perfect description of what this is, because like I said, when we do the stemming, we're actually taking different words and we're kind of reducing them down to the same one. So it's not necessarily proper to say that they're unique, because it's you know, when you take the stem of a word, technically it's not the exact same, right? Like when we have the fish example. Well, I mean, the master example. These are all three unique words, right? But we're only going to be counting it as one. So unique probably isn't the right term here. I don't know. I might need to use a different word for that. But anyway, so what we see here, hold on. What we see here is we see that in the song there's a total of 428 words, and of those 428 words, only 92 of them are unique. So that's where this 30% comes from. Let's just do some quick maths here. Just to double check. Oh, what the idiot. Okay, that's actually not the same. I don't know what the hell I'm doing right now. Anyways, so this is kind of similar to the lexical diversity as I was mentioning before. So what this is saying is that, you know, 30% of the content is unique. The other 60% is repeated from somewhere else, right? So this gives us a measure of, you know, some sense of richness in the text. Like, how deep are these lyrics? Like, is it just the same crap over and over and over again? Or is it, you know, is every word different? So just to give you a comparison, let's go ahead and fix this output. Just to give you a comparison, let's look at a different song. So right now this is Gucci Gang by Lil Pump. Let's look at Reeves Jr. Deposits. Okay, so you can see here this song has a higher lexical diversity. So what's the takeaway from that? Well, the takeaway is that you could say maybe it's like more, you know, it's more artistic to write a song with more content in it, or more unique content. Does that make sense? Like, you can see here this song actually has a lot more words as well, and more unique words. So it's kind of like a more impactful song. And not only that, but it has a higher percentage of unique words. So you could make an argument that maybe that's like a more artistic representation, or I mean, a more artistic expression. Now let's look at Derek Pope Raincoats. Okay, this one has the highest lexical diversity yet, but it's interesting because it really doesn't have a lot of words. It's 280, which is like half of this one, and it only has 64 unique words in this entire song. It's like a 4-minute long song. There's only 64 unique words, and the reason why is because there is a lot of repetition. Like the chorus is repeated a lot. Like I think like half the song is the chorus. Now, with that being said, you might wonder why the lexical diversity here is the highest, because there's so much repetition in this song. Well, the answer is that the chorus itself contains a lot of unique words. if you're familiar with Gucci Gang, you know that it's like the same two words over and over and over. Gucci Gang, Gucci Gang, Gucci Gang, Gucci Gang. Whereas over here, the chorus itself is has a lot more depth to it. Okay. Now, let's actually look at something real quick, and then I'll kind of finish up the video. Hold on, let me make sure. What the? Okay, my computer's lagging for a sec. It's strange. I never really have that problem. Okay, so in the long run, I want to add another statistic that's based on the length of the song in terms of actual time. So not the length in terms of oh fuck. All right, you know what? Forget this. Anyways, if you run these stats, you'd probably see that like Rap God has a lot more lexical diversity because he's really like there's a lot of different words in there. But anyways, so there was one stat that I wanted to look at, which is the lyrical density. So this is different from the diversity. You see what I'm saying? The density is different from diversity. So we need another variable though, which is that we need the song duration so that we can calculate how many words are spoken over the course of the entire song. Now, this variable would be useful to us because it could kind of give us a sense of how fast the song is, if that makes sense. Like I just mentioned Rap God. Rap God is a very fast song. Eminem punches out a lot of words in a very short amount of time. So it's a high word count, low song duration, right? So that would be very lyrically dense, right? That makes sense. That's different from the lexical diversity though, because the lexical diversity measures uniqueness. This measures like quantity, if that makes sense. So I really want to look at this because it'll give us a sense of how fast the song is, and that's just another variable that we can use to compare and contrast different songs. I mean, you see, that's what we're doing here, is we're kind of like comparing and contrasting these two different songs and learning more about it. One of the things I want to do is I want to create this thing that I call the mood score. So I want to use a hexagraph, which looks like this. It's from Pokemon. Ignore the stat names. So if you know, there's like 8 different emotions, like joy, anticipation, anger. So what I want to do, hold on, is I want to make a hexagraph like this and have each one of the, not a hexagraph, an octograph. I want to make an octograph like this and have like a measure of, how much anger is in this song, or like how much fear or how much disgust. So in order to do this, what I would need to do is create a sentiment classifier. And in fact, actually, a sentiment classifier is pretty much along this axis here. If you can see, this is joy and sadness, or like happiness and sadness. So a sentiment classifier is basically a numerical algorithm that will measure how positive a message is or how negative it is. So if you take a look at this here, for example, if someone tweets about your product and they said, my experience so far has been fantastic, that's positive sentiment. You can run an algorithm on this text to produce that calculation, okay? Or you could get neutral sentiment or negative sentiment. You see what I'm saying? So the point is, we can repeat this process for all of the different emotions, and then I want to produce this chart here as sort of like a signature of the song, if that makes sense. Like when you make a song, it's going to generate an octograph, and then that octograph is kind of like a visual representation of your song, right? So that's kind of like the next thing I'm working on. Also, it would be cool if we could do like a recommender system, like to calculate calculate similar artists. So for example, if I start doing a lot of this, if I run this analysis script on a lot of different songs, then I can start to build up a database where I calculate similarity between songs based on the NLP metrics. So if I do that, then I can actually recommend songs. So for example, if you really like one specific song and you say, hey, I want other songs like this, like I want another song that's just as intense, just as powerful, you know, just as meaningful, the system would be able to say, okay, here's some that are just like that, right? So this is like a more long-term application. This is like if I wanted to build like an app or a website out of this, I would use something like this to actually provide, you know, a valuable experience for the user. Right now, I'm just generating stats, that's it. But like if we actually wanted to use those stats, this is the kind of thing that you would do for that. Okay, so let's actually, hold on, I want to do a little bit more typing. What was I gonna do? I totally forgot. Oh, you know what? Okay, anyways, I think that's gonna be about all for this video. If you want me to do other ASMR videos, let me know. It's just that I won't be able to record my face because my phone isn't working properly. Or if I do record it, it's gonna be like messed up, so you know it might look odd. Anyways, let me know if you guys have any like questions about this, or if you want me to make other videos about coding or data science. And yeah, peace out.